Right, in this video we're going to continue looking at factoring, and we're going to look at how to factor quadratics, where this constant here equals 1, because we know that in general a quadratic is an expression ax squared plus bx plus c. And in this one we want to look at where a is 1 and b and c are constants. So let's look at some examples on how to do it. When we factorise a quadratic, we're going to have two brackets. So it's going to be like this, and you can have a go at these problems before I solve them if you like, because you might have done them before. It's going to be x here, because I also need the two x's to make the x squared. And I want to find two numbers that multiply to make 20 and two numbers that add to make 9. So that's going to be 4 and 5. But it's also right if you have the brackets the other way around and you decided to put x plus 5, x plus 4. And you can check by multiplying them back out. So let's just do that for the first one. When we get multiply the x's, we're going to get x squared. Then we're going to get a 4x here, and a 5x there, that's 9x. And the 5 and the 4, when you times them, make 20. So yes, that's factorised right, so we don't need to worry about that. But it's good to know how to check in case you think you might have made a mistake or something. Next one here, we've got some fractions in it, so I think the best thing to do here is to multiply everything by 3 and get rid of them. So then we're going to get x squared plus 2x minus 3. And then we're going to factor that. This one's a minus 3, and we know that to get a minus we need a plus and a minus to make that for multiplying. So one of these is going to be plus and the one of them is going to be minus. And I have to make two, so I'm going to make this one the plus 3 and that one the minus 1. And that'll work. Next one here, we've got a bit of a problem. We can't just factorise it straight away, because notice we've got x to the 4 in here. So what I'm going to do is I'm going to make a new variable. I'm going to I'll tell you what I'm doing here. Let y equal x squared. And then what we get when we've done that is we get a new expression y squared plus 7y plus 12. And then we can factorise that. And we're going to get y plus 4 and y plus 3. And then when we substitute back for what y is, which means everywhere we see y, we just put back the x squared. So we're going to have x squared plus 4, x squared plus 3. And that's going to be the answer. Or if you like, maybe you could factorise this expression here a bit more, because you can see that x squared plus 4 is going to be x plus 2 and x plus 2, and then you have x plus 3 squared. But you don't always have to do that, but if it says factorise something, I guess you should factorise it completely, so in that case do that, last step. because generally we do factorise things completely. Next problem, we're going to let y equal the square root of x. So we're going to get x squared. Sorry, this should be y because I'm substituting. I'm going to get y squared plus 12y plus 35. Then I can factorise that. And then we'll put back what we had before. So square root x plus 7 and square root x plus 5. And that's going to be our answer for that problem there. Next one, we're also going to make a substitution. I'm going to let y equal x to the n. And then we're going to have y squared plus 9y plus 8. And then that factorises to that. And then we'll substitute back. And we're going to get that. So that's the answer to the original problem. Pretty easy. If you notice the substitution. This one we don't do a substitution. What we do is we'll see that there's an x that's a common factor to everything. So what we're going to do is we're going to take that out first. And then inside here we're going to be left with x squared plus 13x plus 30. And then this bit inside the quadratic, so we can factorise that. I'm going to get x plus 10 and x plus 3. And as usual you can multiply them all out and see if you get the right answer. And this is the general method. You factor an expression to this. You make a substitution if it's not already a quadratic to make it one. And then of course if, like in this last example, there's a common factor to all three terms, we'll remove that first and then we'll factorise the quadratic that we've got left inside the brackets. So that's the general method for if a is equal to 1.